So let's come to security operations, automations, and response, and how Windmill is used there. So a lot of our customers use actually Windmill for security operations, automation, and response. We even have vendors like managed security platforms that are using Windmill under the hood. We call it like the white labeling use case. So they use Windmill under the hood to expose to their clients through their product, like playbook management systems. So you might be surprised to see that potentially other vendors that you'll encounter under the hood actually use Windmill for their playbook management systems that they might have. So the reason why we see a lot of use in SOAR use cases is that our customers start maybe with a managed platform from one of the major providers, but quickly or typically after a while outgrow the features, because every organization is very specific. Specifically, larger organizations have their own IT, and it's not everyone has the same databases, like identity management systems, etc., etc. Some things get even proprietary or local, or I think specifically in the government use cases, you have some systems that don't exist outside. So the typical APIs and integrations that exist are not there, and you have to use your own internal APIs. So eventually our customers realize that the managed systems are very rigid and maybe don't fit exactly their use cases. And this delta where you have the friction is you will then have to interact with the provider, and they may or may not develop a feature. You'll be waiting, and you don't have full control. And here, the advantage of Windmill being open source also means you can actually develop or integrate your own components if you want. But also, since we're code first, you can actually go in and modify like your own code, or you build your own APIs individually. So recently we had a big customer coming over from Palo Alto Networks. The organization has like over 10,000 employees, and their security operations teams like multiple, I think 100 people. And they realized that this was exactly their problem. Their workflows and playbooks got very complex because their infrastructure is complex, and they weren't able to map their playbooks anymore in their system. So what they did is they basically migrated over to Windmill because it gave them that flexibility that they needed. So as I mentioned, we use real code, so we can use real code, but also obviously existing integrations, pre-built, the ones we have in our hub. You can iterate instantly on your script. We have a lot of testing features. And for example, if a new tool comes online and there's no integration yet on the managed provider, you can actually use the SDK or the APIs directly from that new tool. We are fully self-hostable and open source, as I mentioned, and we're basically automation first. One thing also to say is that a big advantage I also see is that we have no lock-in. Your scripts stay basically, like if you have existing scripts like Python or whatever, when you use them in Windmill, they stay exactly the same. If you want to move them back to your own systems or to another system, there's no, migrating it away or lock-in, basically forcing you to adapt a specific pattern that only works with Windmill and then doesn't work anymore in another system. So another big advantage is the lack of vendor lock-in, let's say. Use cases in SOAR, I think, are pretty clear. We'll go through one in the demo in a second, but I think the biggest one is like enrichment of your incidents, or like your automated alerts with external tools like intelligence tools, etc. automatically trigger your playbooks when something happens, or manually trigger it if the security analyst sees the need. Big one is the suspension and conditional approval and, let's say, requirements of additional inputs to workflows, or basically automatic responses like isolating machines, disabling accounts, etc., etc. An example workflow is here very simple, and on the right we see how it would look in Windmill. Is like, let's imagine you have a webhook from your email scanner. So you have an email scanner, you see an email coming in with suspicious body or an attachment even. This could be a trigger to a Windmill workflow, as we see here, where the following steps are happening. We extract sender, subject, body, and attachments. We, for example, call threat intelligence API with some of the payload to get like a risk score, for example, or potential other data points. And then basically we can have a branch where we say, okay, it's suspicious, yes. Then, for example, send a Slack message to a channel or create a ticket. Ask, for example, for approval to disable that user or quarantine the user, and then basically log the steps that have been taken into a ticketing system or an audit log, etc., or basically into your SIEM. Before going to the demo, like some final words here. As I mentioned, security operations is not the only use case for Windmill, and as our platform is not primarily a security operations platform, but more generically a workflow automation platform, we have tons and tons of different use cases across many different industries like finance, healthcare, automation, supply chain, and security. So it really gives you a lot of flexibility, and we see a lot of cases where some of our customers start using it, for example, for their security use cases, but then they realize, oh, that's super useful. They showed it to some of their colleagues, and then they're like, oh, it's going to be very useful for our HR onboarding process. And then, you know, suddenly the onboarding playbook becomes a Windmill script. Or, for example, we even had a use case where a company used it to create an app where they could ask their employees what menu they want to order for lunch. So it's really up to you to define where the limits are of what you can do with Windmill. Okay, so this might sound still a little bit abstract, so we'll jump in a demo before we come back to the slides, so that you can kind of see a bit how this works and how this works in action. So this is now Windmill. I'm running it on my local system, as you can see here, but you know, we also have a cloud version. And basically how Windmill is organized is we have an API server connected to a database. The database is really the core of Windmill. It contains basically the queue of jobs that need to be executed. So let's say I have a script here, as I mentioned. One script could be disable user, which basically just calls an API to disable username. And if I run this script, what will happen is a job for the script with the inputs will be put in the queue, and then we have workers that will pick the job from the queue. So basically, the scaling of Windmill works by, you know, adding an appropriate amount of workers. The workers can have access to different resources, etc. But basically, a worker is basically an executor of jobs, and any script that you run or any workflow will be pushed to these workers as jobs. So we have scripts here as the first step. As I mentioned before, we looked at certain scripts. So one of the scripts I want to show as an example is for example, calculate risk score, right? So, and yeah, so here the script is, in this specific case, a Python script, and it takes as inputs a bunch of different, let's say, factors or arguments like failed login numbers, threats, infected. You can see the types of these different scripts. And here I created a very simple heuristic rule saying, assigning a score to each event. So I can say, for example, if failed logins is larger than 5, give it a score of 20. If the virus scan was positive, give it a score of 40, etc. So you can easily create like your own logic here, and then at the end basically say, okay, the combined risk score is the sum of all these individual points. Severity is the final classification here. If it's larger than 100, 70 or 40, etc., we can assign it a specific severity. And then here we say, okay, should we create an automatic response, yes or no? So that's an example of a script. And I can also show you what I mentioned before. We have this AI feature, so I can say, I think if a virus is detected, we should give it a higher score. So if you type something like this, as you're familiar with maybe similar tools, it will basically show you like a diff and say, okay, let's increase. I mean, that's a little bit of an easy one, maybe too easy for an AI use. But yeah, you can say, okay, apply this change. It explains what's happening. And you can say, okay, I want to increase here from 40 to 60 so that it does a higher weight. So this is basically the AI integration in action. So yeah, a script can have triggers. So you could say, run this script through a webhook. So if you call this API endpoint, it will trigger the script. You can have schedules. So you can say, for example, let's, again, here you can use AI, run this every first Monday of the month. And it will create a cron syntax for you. Basically, you'll see here, it will create a scheduled job every first Monday of the month. So schedule is basically cron. So when do you want to run this? You can create HTTP routes. You can have WebSocket triggers, Postgres, event streams. So you can have your different types of queues, NATs, MQTT, etc. Or you can trigger a script via an incoming email. So each script, as I mentioned in the introduction, is basically an atomic operation. In this case, calculate risk score. If we go back, we see that I created a bunch of other scripts like query SAML, query threat intelligence, retrieve identity, summarize incident with OpenAI. That may be actually an interesting one to look at. So here we use a library called OpenAI, which is basically a ChatGPT SDK, and we take events, threats, audit logs, and other parameters, create a prompt. Here, use the OpenAI API key. I'll show this a little bit later, and then say, basically generate like a summary of what's going on. So that will then basically create a response. So an important thing here is that we can see here, we take as an input something called OpenAI API keys, right? So API key is a secret. So how do we deal with secrets in Windmill? The way we deal with them is through something called resources. So we have a bunch of resource types that are supported out of the box, but you can create your own resource type. But for example, the resource that we're using here is an OpenAI resource. So we have here an API key, which is a secret. So I can manually load the secret value. It's going to create an audit log for each access of that secret value. I could also import that secret from a secret management systems that you already have, like a vault, etc. So so resources are not going to be directly available, but they can come from an external system and can be defined in a secure way. These resources are encrypted if you use Windmill, and anyway encrypted if you use your key management system for those. So you don't have to hard code your secrets, passwords, etc. in the script themselves, but you can reference them using those resources. So if we go back to the script, summarize incident, when I'm picking inputs here, the OpenAI is a resource as an input, and I can select the one that I've seen here before, so the ChatGPT API. Yes, I see we have a question.
Yeah, on the secrets, can you lock down like who can see the secrets?
Yes. So in Windmill, generally permissions are based on folders. So we can see here that we have a folder called SOAR, and here I have right now only one user. I could add users or groups, and could even specifically add permissions for individual resources. And if a resource like this one is an OAuth token, it can even be tied to the user itself and have a refresh token, so you can only have it tied to the user. But basically, it's a flexible permissioning system where you have scopes of user groups, workspace, and basically everyone. So you can define access roles on any resource, script, schedule. Pretty much anything that Windmill touches is based on those access permissions.
Yeah.
Now,
thank you.
The users are either defined in Windmill, so you can have password-based users. But here we can also see that I have a user that is basically synced through SAML. So you can define your own SSO connections and basically import users with SIM, SAML, and not only the users but also their groups. So this also allows you to basically not have multiple user management systems, but use your existing organizational one and import the groups and assign scripts to those groups that already exist in your identity management system. All right, so scripts. We've looked at some individual scripts right now and how they can use individual resources that are basically tied to secrets. Now, as a next step, we'll look at flows. So we will combine these individual, and actually let me go into the editor because it's going to be more visible. But now we have our individual steps, and we want to create a playbook. So how would such a playbook for a SOAR use case look like? And yeah, I spent a couple hours yesterday to create one from scratch, based on some of the stories that I have from our customers building similar types of security operations playbooks. So first of all, the triggers. We can, for example, imagine that we have an intrusion detection monitoring system that triggers an alert on specific payload. So we would configure if this was a real scenario, we would configure our IDS to call this API endpoint with a bunch of input fields. And these input fields would be username, IP, host name, timestamp, alert type. Again, this is just an example. It could really be any type of field that your intrusion detection system would provide. So that will come through a webhook, but you could imagine that some of these IDS systems could also emit an event stream to a queue like Kafka or any other type of queue, or even potentially WebSockets. But but really, I think webhook is a very common one. So assuming this webhook comes in and provides us a payload, we can have a preprocessor run that does some basic, formatting or validation of the inputs, and then we pass it into the workflow. So the first step really is not that interesting. It's just creating an output for a later step that we'll use to actually associate it with a dashboard. But the interesting parts come now here. We have our first branch that say, okay, run all branches in parallel. So when we get the event, we want to do all these things in parallel. So first one is query our SIEM, query the threat intel API, query our identity system, query our compliance system, and query our audit logs. So all of these scripts here, so if we look at one specifically here, we see that here we're using one of the scripts that we've seen before in the script editor. If I click edit here, we actually jump into the script editor we've seen before. So a step is basically a script, as I mentioned previously. So we say, okay, here we're going to run the script, and we're going to take as input of the script the username coming from the flow input, the IP, host name, etc., coming from the flow input. Same for threat intel. The threat intel API only takes flow input as an argument. Our identity system will only take the username as an argument, and so on and so forth. So each script may have their own inputs, and we map the inputs of our flow, so what comes through the webhook, to the inputs of our individual scripts. Now this branch all will basically run them all in parallel. Then we collect all the results. I mean, here, this is a branch that actually has two steps, not just one, because the virus scanner requires us to first get some metadata from the identity retrieval step. So we see that here it takes, we need to first get the host names associated, so the devices associated to the user. So we run the user identity retrieval script. The identity system returns a list of devices, and then we basically call the virus scanner on these devices to get any type of report from these devices. Then we collect all the results from all these branches, compute the risk score. We've seen that script before. We compute the risk score based on all these inputs. So we classify it in low, medium, high severity and give it that risk score number. We pass that to the step where we send all of that information to the OpenAI summarization step. So the script we've seen before, where we create this prompt with all the inputs from all these previous steps, and say basically give us like a summary of what's going on, like what you see given these data points. We create a ticket here. I'm using a linear API. This is our internal ticketing system, but it could be ServiceNow. It could be, we have a bunch of integrations to different ticketing systems. So we have a simple step, create a ticket with this title, the body, severity, and the body comes straight from the OpenAI ChatGPT, basically summarization. Same with the title, and then depending on the severity of the issue, we have different remediation steps. So for example, the default step would just be to log the incident in our SIEM. It's low, just log it. If it's a medium step, we have created the ticket already. We're gonna send a message to our security operations Slack channel to notify the team that there's been a medium severity incident, but then we don't do anything else. Now in the high incident, we're deciding to not take automatic action, but we actually request interactive approval. We're going to see this live in a second, but basically instead of saying, oh, let's quarantine the host immediately and lock out the user, we're going to ask an analyst to review manually and then directly in Slack approve the quarantining or say, okay, that's a false positive, we're keep investigating, but we don't need to immediately lock it down. And for critical, the difference is we're gonna automatically lock down the user. So you can basically map your own business logic here. And obviously this really is like use case specific. You may or may not want to do any of these things in your use case, but the remediation steps are basically following classification and enrichment phases of your security operations workflow. And at the end, we basically return the outcome of the flow, and basically are ready to execute the next flow. So to recap, this whole flow is triggered by a webhook from some automated system like an IDS. You can define your own workflows. Here we have the enrichment phase, here we have the analysis phase, and here we have the remediation phase. Now let's run this. So when I can go to test flow, I can go to the history of runs, and I can pass it some inputs. So this is basically an input simulation of what the system, the IDS, for example, could send you. I can run test. And now what's happening is you can see live how the flow is being executed. Right now we're in the summarization step. We were already retrieving all the informations from our other systems. So the summarization took 12 seconds. Now we realize we're in the high use case. And now what we see is that we're suspended in this state. So it says request interactive approval from Slack. So the flow is suspended right now and needs further input to continue. And I'm gonna switch to Slack, and we see that, imagine this will be your Slack or whatever system you use to manage your security operations team. You would get like a notification, a flow has been suspended, please approve. And here you can actually ask the analyst to provide some input. And this input, again, could be used in the workflow to do some further decisions or go into a different branch of the workflow. So here it says like submit an approver. I'm gonna say Alex, then I could like look at the ticket, look at some other fields from the event. I see login failures, I see the flow ID, I can go to the ticket where I see the summarization. But I decide to quarantine the user and resume. So I click resume, and if we go back to the script, we'll see that actually the flow continues, and we have disabled the user. So we went into this branch, we sent a message to a Slack channel, and we finalized the flow with the result, which is basically all the data points that the playbook was generating. So now what happened in this specific case, we can go to our ticketing system. Let me quickly pull that up and show you an example of ticket that has been generated. Yes, can you see the, yeah, I think, yes, you can see the screen. So, so if we go back here, where was it? All issues. So you can see here that this is, for example, the output of the ChatGPT step, critical security breach, and the summarization and the flow ID, a link to basically the flow where you get all the actual details of the event. So this would be a ticket that has been generated. And what we also see here in Slack is it created a link to a dashboard that was generated. So this dashboard, I'm gonna copy paste the link so it opens it in the right browser. This dashboard is linked to a Windmill app. And now we're actually at the last step of Windmill. You remember we had scripts, workflows, and now apps. So apps are basically, as it says, like a front-end app for maybe a non-technical user. And what we did here in this app is we fetch the result from the workflow and we render it in some meaningful way for the SOC. I mean, here it's mostly just summarizing and showing the information. So we, for example, take the username, host name, detected, IP address, the text from the AI summarization, audit log, threats, compliance, etc. So all of these are pre-built Windmill components. So if we go to our app editor, the app editor really is a drag and drop app editor where you can configure all these individual panels and tabs and UI elements to take data from specific things. So in here, we can see, for example, that we have something called runnables, which are basically, again, Windmill scripts that do something. So we have here one script that is called get location from IP, where we pass an IP address and then we call IP info API endpoint to get the location. We then here in this map component, we basically say use the result from BG0, which is this background runnable, use the longitude and the latitude to actually zoom into the point of where this event was detected. So you can link these different UI components to data points coming from those background runnable scripts. So for example, here we have the audit logs, right? So BG1 results audit logs. So what's BG1? BG1 is get job result. And the job results are nothing else than what we've seen before when we ran the workflow. We retrieve the results of the workflow, and then we see that the workflow returns all these fields here, and we can just use these fields to populate a table. So you'll see here we have a lot of different UI elements that you can just drag and drop here. So you can have an S3 file uploader. So for example, you could upload files locally from your system and then do some processing on those files. We have tables, we have decision trees. Yeah, pretty much what you could imagine like useful for building like a front end. So basically, this ties the whole story together from like workflows, basically individual scripts, so the steps from the workflow to the workflow itself to then creating dashboards. And I think with this demo, you also probably get a grasp of the flexibility of the system, meaning, you know, security operations is one example, but how you could probably map any type of internal process or workflow into basically Windmill, and why I think Windmill is very powerful in general, because it gives you really that flexibility where at one point, if your organization grows, like you'll reach these edge cases where your typical SaaS will no longer work for this because that specific feature doesn't exist there, or that integration doesn't exist there, and you'll end up, you know, waiting for a feature request to be implemented, or, you know, manual development of a specific feature. Where in Windmill, since we're basically taking a higher level abstraction, you'll be able to just write that as a script yourself, either with an existing script that you already have in your organization, or using an AI, for example, tool to generate that script for you, which can be done inside of Windmill. Okay, so as we're getting close to time, I want to have some time to, you know, discuss if you have any more questions, but just what are the typical next steps that we encounter when we work with our customers at this stage is that we have our open source version, which basically is fine for many use cases where you don't need enterprise tools, such as what I showed before, the integration with SAML, like your identity management systems or external secrets management systems. A lot of the use cases can be done with the free open source version, and you won't even need to have an enterprise license. If you need some of the enterprise features, it's actually very cheap, and it starts with $200 a month with 4 workers, which already can handle a lot of concurrent jobs. It always kind of depends how many active users you will have as developers at Windmill. We do the distinction between developers and operators. So the pricing really depends on developers and operators and how many workers you have that execute those jobs. But nevertheless, we offer 30 days free trial for enterprise users where you also get our support for onboarding, and you can basically try it out and see whether it's a good fit for you or not. And we typically encourage our customers to take a representative workflow, like one of your playbooks, map it into Windmill. It usually should be very quick to develop that, and then basically see whether this kind of mode works for you. And yeah, I hope you have a better understanding of what in general a workflow engine is and how Windmill could potentially map your use cases.